complete sentences, explain the key features of the graph of the sine function. Okay, so this is a grade 11 problem where it's approaching sinusoidal functions for the first time. It says explain key features of sine function. Okay, so we're given this sine function here. They actually use Desmos, which is nice. And what we're doing is we're explaining the key features, right? So we can say key features of sine functions. We can use the complete sentences. I'm just gonna verbally say my key sentences, so it's not tedious for me to write. But I can say a sine function is continuous, right? It has it extends in terms of x. Its domain is x is all real numbers, right? So for a sine function, if f of x equals sine x, domain, for example, the domain of this function is xer, right? Xer. It exists in all radians, right? Obviously it repeats and repeats, but xer for those periods as well. And then my range, for example, as you can look at the y-axis here, it goes up to 1 and it goes down to -1 here. So so for y has to be between -1 and between -1 and 1 here. So y has to be that, and y is obviously all real numbers as well. So that's my domain and range for this function here. I have an x and y intercept of 0 and 0, so I can say my x intercept, y intercept is 0 and 0. Or my y intercept is actually just 0, right? Because I have multiple x intercepts. So let me rewrite this. So y intercept is 0, 0. X intercepts I actually have it consistently changes to there's an interval, right? So like if you look at the graph here, at 0, 0 it crosses the x-axis, at pi it crosses the x-axis, at 2 pi and so on and so forth. So it actually crosses at x-intercept is at n pi. So if x is at n pi, so here it's every n pi. So where n equals basically basically any integer, in this case any integer. So it's like 1, 2, or plus or minus 1, 2, 3 and onwards. So basically that's kind of my condition for my x-intercept here. And as you can see, there's you can see other functions here. There's an amplitude of 1. Amplitude of 1 meaning that it goes towards 1, and its max is 1 and its minimum is 1. So I can say maximum is 1, minimum is -1. And I can also say its frequency, right? Its frequency, or sorry, in terms of period, right? Period. So for one cycle of the function is every 2 pi, right? So it goes up, as you can see, it goes from 0, 0, from 0, 0, it goes to pi over 2, goes to pi, goes to 3 pi over 2, and then it goes back to 2 pi, and then it keeps repeating this pattern, right? So every 2 pi is one cycle, or one full cycle of this sine function here. So I hope that's enough information for kind of the sine function here. I have domain, range, y-intercept, x-intercepts, maximums, minimums, and periods. And I think that's about it in terms of this function here. So let's say, as we can see, the graph goes up 1 unit, down unit from the middle line. So the amplitude of the graph is 1. That's good. Since sine is a periodic function, it repeats its value or cycle after a value of 2 pi. Hence, the period of the graph is 2 pi. From the graph, we can see the maximum value is 1, minimum is -1. And the interval of 0 to 2 pi, the graph of sine has 3 intercepts. So this here is good. I would have liked to include a domain range, and also how my x-intercept repeats every n pi here. But that's about it. I can't really ask for more here. So maybe I'll say this is a good solution. You can also include domain and range of the sine function, and also specify that x-intercepts exist for every n pi, where n equals, and this is plus or minus 1, 2, 3, and so on, so on. Basically every integer. So for that, because again, it repeats both for the positive and the negative signs here. So this here is correct. This solution here is correct, but you can also include a little bit more information when we talk about this graph here. So the solution is correct.